Welcome to the video on derivatives of exponential functions, part 1. In this video we're going to talk about exponentials with base e. So we're going to consider the function f of x equals e to the x. And we want to find the derivative of this function. And to do that, in this case we're going to apply implicit differentiation, and we're going to use a little technique that is useful not only for this function but many times helps you to simplify some calculations. So what we're going to do is to apply the natural log to both sides of this equation. That is the definition of the function. So we apply the natural log to both sides, and we get that the natural log of f of x equals the natural log of e to the x. But by definition, what is the natural log of e to the x? Well, here we can take the x here that is on the exponent down here, and the natural log of e is 1. So this equals x. So we get that the natural log of f of x is x. And now we're going to use implicit differentiation and apply the derivative to both sides. And this will simplify some things. Will simplify the calculation because, well, we know how to take the derivative of the natural log. But here we need to apply the chain rule because this is a composite function. We have the natural log of another function, so we need to apply the chain rule. And the chain rule says that we need to first write the derivative of the outer function. Here the outer function is natural log, and its derivative is 1 over f of x. And then we need to multiply that by the derivative of the inner function, that is f of x. And that derivative is f prime of x. That equals 1. So we get this equation, and here we can simply multiply both sides by f of x to get that f prime of x equals f of x. But f of x is e to the x. So we've arrived to this amazing result that the derivative of e to the x is e to the x. So we found a function whose derivative is the same function. So let's solve some examples using this new formula that we got. For example, let's consider this function f of x equals e to the 2x, and let's try to find its derivative. So here we have a composite function, and the derivative of the outer function, well, the outer function is e to the x. E2 is the exponential function, and its derivative is the same function. And we multiply that by the derivative of the inner function, that is 2x. So the derivative of the inner function is 2. So we get the final answer. That is 2e to the 2x. Let's consider this function here. Here we have the product of two functions, so we use the product rule. We're going to name e to the x the function u, and sine of x the function v. So we apply the chain rule. The derivative of this is e to the x times cosine of x. Here e to the x is u of x, and cosine of x is the derivative of sine of x, that is v prime of x, plus e to the x times sine of x. Here this e to the x is u prime of x, that is the derivative e to the x, times sine of x, that is v of x. We can factor the e to the x here, and we get the final answer. So that's all for now. Two simple examples, and in the next video we're going to talk about exponential functions with bases being numbers other than number e. So that's all for now. Thank you for watching, and see you next time.